This part of the tutorial is about data tables. Now, data tables is where you start with a project. This is your starting point, rightly so, because JMP is a statistics software. So without data, there's not much for JMP to do. The first thing that you do with any project is basically load up a data table. Data tables look like this. This is a blank data table. And as you can see, it has one column and 0 rows. Now, when you look at this, you might think that this is something like a spreadsheet, something that you are familiar with from, let's say, Microsoft Excel. But it's not a spreadsheet. The rows and columns, they're not interchangeable as they are in a spreadsheet. Columns have specific meanings and rows have specific meanings. If you're thinking about this from the experimenter's point of view, columns are the things that you're measuring. So they're your variables. They're either some kind of an input to a process that you're investigating or the output from that process. So it could be the performance of the process. The rows are different experiments that you're running. So they're either repetitions or experiments with different settings. But whatever it is, one row is basically one entity. All the numbers in different columns for one row, they go together. They come from the same thing. However, columns are just different measurements, so they can mean many, many things. The other things that the columns can be are formulas. So you can take numbers from column 1 and some column 2, and maybe you can add them and call that column 3. So column 3 can be a formula. I will show you how this works in a later example. You probably also noticed that this window showed up in our window list right there. And it has its own file, edit, tables, etc. menu. It has its own sort of shortcuts. It also has these left side panes, and these are very specific to data tables. The top one is where your scripts about the data table will live. So you may create some scripts that do some automatic analysis for the data in the data table, and they will live here. The middle one shows you your columns, and this is kind of useful if you have way too many columns, and this will give you a better view of the different columns that you have. It will also give you some interesting properties about the columns. So this column is a continuous data column, which is shown by this blue triangle here. Different kinds of data columns will have different symbols here, and we will see how the other ones look like. Then you have the rows part. This will show you how many rows you have selected, excluded, hidden, labeled, etc. So this gives you kind of like an overview of how many rows you have. And you can have millions of rows. It's impossible to look at them all, but here you have a nice summary of how many rows you have. But an empty data table is not much to look at. So let's go ahead and import some CSV file and use that as an example for a data table. I'm going to go ahead and click open here. I do have a CSV file here that is kind of fun to look at. It has all the extrasolar planets listed in there up until the ones that are discovered up until today. I'm going to go ahead and open this with data with preview import option. Here's what that CSV file looks like. Let's go ahead and make this a little bit larger. In the first few rows, we have information regarding what's recorded in the columns. So if I scroll down, there's so much column information. And as you can see, there are many columns here. How they were discovered, who discovered them, which telescope they were using, things like that. In the specific CSV file, we have some lines that precede all the data, and they are denoted by this pound sign. These are information that humans may need. So I know as the analyst that ST_color_N means the number of color measurements. So I understand physically what that data column has. This row right here, this line right here, includes the column names. So PL host name, row ID, etc. My data starts here with this 1 comma part. So these will be my experiments. So these will be my rows, and that will be my column names. So I need to tell JMP that it needs to ignore all of this with the pound sign stuff. One thing that I can do is I can just go ahead and import this and then delete all those lines afterwards. But let's try to figure out how to do this properly. I'm going to guess that there are, I don't know, there were a lot of them. So maybe, I don't know, 100 lines of information that JMP doesn't need. Let's see what that does. Oh, we're actually pretty close. I think, yeah. So it's there. It's definitely more than 100. Let's try 125. Okay. 6, 7, 8, 9, 10. So that would be maybe 131. Oh, 130 is the correct number. Okay, so I told JMP that the row 130, the line 130 has all the column names, and my data starts at 131. There we go. You can see that these are a little bit bolded and these are regular, and everything else is kind of grayed out. I like how this is looking like, so I'm just going to hit next, and this is fine. Usually you can go ahead and correct JMP if it thinks that the column names are a little bit, column types are a little bit weird. You can change them, but it's okay for now. You can change it later after you import it too. I'm going to go ahead and import this data now, and it creates a data table. As you can see, our data table is here in the window list. It gives it a name based on the file name of the CSV file that it imported. So that's all looking good. I'm going to go ahead and maximize this because we're going to be investigating this heavily. And you can see that, I can only see so many columns, but here it tells me that there are 126 columns and there's close to 2,000 rows here. So these are very useful in terms of, looking at the data in kind of like a summary way. And you can already see that some of these columns have different symbols in front of them. So PL hostname is a little bit different than, let's say, PL pnum. And this is because some of these columns have numerical values. So JMP realizes that these are sort of continuous values. Actually, in the case of PL pnum, it's not a continuous number, it's a discrete number. And we can fix that. What we can do is we can right click, we can go to column info, and we can say this is a numeric data, that's correct, but it's not continuous, it is actually ordinal. So it has some kind of an order to it. Hit OK, and now we have a numerical data which is ordinal. So you can see that there's some kind of order to the numbers. When we look at this PL hostname though, this is a data type that is not ordinal. So this is a nominal data type, and this is correct because it's just the name. So you can definitely order them in the sense like you can order it alphabetically, but when you put it in a number line, there's no order to them. There's no way that you can integrate over that data based on the alphabetical ordering. So this is a character and it is a nominal data type. So JMP got this correct. So we can leave it as that. And you can go on and figure out whether JMP has made any mistakes in the other columns as well. But for now, we're going to focus on other things. The first thing that I want to show you is how to get rid of a column. This row ID column here is not really doing anything useful because it's basically the same number as the JMP's row numbers. And we can see that if you go all the way to the bottom of this data table. We can see that, they are basically one-to-one matches. The first column is not doing anything useful. So what I'm going to do is right-click on it and delete that column. And there we go. That column is now gone. It's not part of the JMP table anymore. And we can, we just simplified our data just a little bit. So you can do that as well. You can delete that. You can delete columns. You can also add columns. So if I right click here, for example, I can add a new column. I can add multiple columns if I need, let's say 5 columns. I know I need 5 columns. So I can add multiple columns. And you can go in there and you can figure out how many columns you want, how you want to name them, and where you want those columns to be inserted. You can select multiple columns at once. That works. So you can do the same thing on multiple columns. You can select many rows. That works too. If there are some interesting data points that you want to investigate, you can select them, right click, and maybe change the color. Now that data line, that data point will look different on all the graphs that you're going to plot. It's going to look red. Also in the data table, it is labeled red, so you can go back to it very easily because you can notice it. You can also change the marker that it will have on the data table. So let's say you can select an upside down triangle, right? You can do that as well. Then there are some other options that you can use with data points. You can clear them. You can select matching cells. So if you had labeled a bunch of these and you want to select them all, you can do that. You can invert the selection, etc. You can delete rows as well. I'm going to go ahead and clear all the row states so we don't get confused. But this is basically it. This is the basics of a data table. One thing that I forgot to mention is that there are these bulleted cells in our data table, and this basically means that JMP expected some data there, but there is no data. So those are missing values. And based on how much of the column is populated, you can actually ask JMP to try to guess what that number would be. And if there is some kind of an order to, your data, it will do a fairly good job. But unless you need it, never fill in missing data points. Only do that if you really, really need it, because technically that's fake data. That's not data that you have collected. It may throw you off when you're doing some other analyses. So don't fill them in unless you really, really have to. So this is the basics of a data table. Next up, we're going to look into some graphing options. But before I finish this, I want to go ahead and save it. So I will hit save. I can see that it will save it as a JMP file. I can select Excel workbooks or just text and CSV, etc. But JMP has its own format. And this is really nice because you can save some scripts here within the data table, and it will save all of those scripts as well within this JMP file. So this is actually a very good sort of format if you know that you're going to continue working on this file using JMP, which we will be. So I'm going to go ahead and save it as a JMP file. And now that it's saved, we are ready to look into how to visualize this data a little bit. So that's going to be the next video.